Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 5-5 for Course 2, Using Similar Figures. Our objective is to use proportions to find missing lengths of similar figures. Okay, so we do have a couple of key concepts and vocab words that we want to talk about. First of all, similar polygons. Two polygons are similar if their corresponding angles are congruent. Congruent is the geometry term for of equal measure or of equal size. So if they have the same measure. And the lengths of corresponding sides are proportional. Okay? So basically, kind of just rephrase that a little bit. Two polygons are similar if they have exactly the same shape, but perhaps not the same size. Okay, so they're going to be, the shape is going to be the same. One is generally larger than the other. Okay. A polygon is defined as a closed plane figure formed by three or more line segments that do not cross. Okay, so a polygon would be a triangle, a square, a rectangle, pentagon, etc., etc. Two-dimensional, that's what we mean by a plane figure. All right, and indirect measurement is basically what our focus is here. It is a method to measure distances that uses proportions and similar figures. Okay. All right. So let's get right to it. Finding a missing measure. Triangle ABC and triangle DEF are similar. Find the value of C. Okay, so we have two triangles here that have the same shape. One is larger than the other. One is also oriented on the paper a little bit differently than the other. If you're not sure what to match up, A matches D, B matches E, and C matches F. Sometimes that's helpful when the figures are either rotated or otherwise translated or oriented on the paper differently. Okay, so we're looking for C. So we can write a proportion using things that we know and things that we don't know. So first of all, the length of AB is C, so that's why we have C here. AB in this triangle corresponds to ED in the larger triangle, or DE, I should say. And the length of DE is 18, so I'm going to fill that in with 18. AC is the shortest of the three. AC is 6. DF, in the larger picture, also the shortest of the three, is 9. Okay, we can write 6/9 in simplest form to give us 2/3. And then from there, 3 times 6, 3 times 6 is 18. So 2 times 6 is C, and C is 12. Now, please don't get caught up in having to do this in the circular motion. This is simply just doing an equivalent ratio. So just like equivalent fractions, you can do 3 times 6 is 18, so 2 times 6 is 12. That's all this is. It's just a little different way of presenting that. So mental math sometimes is helpful if the numbers are easy. Go ahead and use it. Our second example is actually doing some indirect measurement and using it. So this would be an application. A 5-foot person standing near a tree has a shadow 12 feet long. At the same time, the tree has a shadow 42 feet long. What is the height of the tree? You're given some choices here. Now, the idea behind this is that we can use the height, the person and their shadow make two legs of a right triangle, and then an imaginary hypotenuse or third side connects them to be a triangle. Same thing here. The tree forms a right angle with the ground on which the shadow lies, all right? And then again, from there we connect imaginary third line. Okay, so I do highly recommend drawing pictures for these because it helps you orient yourself and understand what's going on. So draw a picture and let X represent the height of the tree. Write a proportion. So the height of the tree here matches the height of the person here. So X over 5, height to height. Some kids even like to do this so they kind of keep track of what they've matched. And then 42 to 12. We're doing the tree shadow to the person's shadow. Now, as we'll discuss in class and have several times, this is not the only way to set up the proportion. Since it's already done somewhat for us, we're going to follow the way the problem was laid out, but it's not the only way to do it. Now I'm going to do cross products. X times 12 is 12x, and 5 times 42. 5 times 42 is 210. I'm actually going to mark that out and write 210 there so you have a check number for yourself. And then 210 divided by 12, is actually 17.5. Sorry about that. 17.5. So the tree is 17.5 feet tall. So our correct choice is answer A from the multiple choice questions. And it's really that straightforward. The whole crux of the problem lies on setting up your ratios in the same manner. In this case, again, I went tree to person, tree shadow to person shadow, okay? Or large to small if you consider the triangles. Sometimes it's helpful to jot that down. Okay, those are the examples in this particular section. You have a couple of quick checks. So if you'll have those ready for next time we meet, we'll discuss. Also bring in any questions about something that you may not have understood.